under decimals, guess what today is?
Multiply.
Decimals, today, ladies and gentlemen, we multiply. We multiply. Now here is your, for example, let's say I have 3.6 times 0.41. Okay. Please understand, like I said before, we just got done adding and subtracting decimals. Okay, that rule does not apply. You don't have to line up the decimals. I mean, sometimes they may end up being lined up, but you don't have to and don't. Okay, just keep that in mind. That's only adding and subtracting that you line up decimals. The rules for multiplying decimals are pretty simple. Okay, your first step is to multiply like normal. Pretend there's no decimals there at all. Multiply normally. Which means I'm going to take, I'm going to write it down, it's 3.6 times 0.41. Doesn't really matter, I probably should have done that. Let's at least line up the digits, not necessarily the decimals. Times, oops, sorry, I'm going to get there, times 0.41. Doesn't really matter, I probably should have put the 3.6 on the bottom. Let's do that. Or let's just skip the 0. How about that? We don't need that there. So it's really 36 times 41. What is 36 times 41? 1 times 6, 1 times 3, 0, 4 times 6 is 24. Carry the 2. 12 plus 2 is 14. I get 6, 7, 4, 1. Those are the digits I get. The problem with this is I need to figure out where the decimal goes, and that's what our next couple steps do. Step number 2 is in the numbers you multiplied, comma, count the digits that are to the right of the decimal, or decimals, I guess it is. I'll give you a chance to write that and go a little slower when we do this here. Count the digits that are to the right of the decimals. It's a little high for my liking. In other words, children, the two numbers I multiplied together, this one has 1 digit to the right of the decimal, this one has 2 digits to the right of the decimal, for a grand total of 3 digits to the right of the decimal. What you need to do is then, step number 3, start at the right of your answer and put the decimal left the number of places from step 2. And again, this is a lot of words for a very simple little procedure, but if you don't write them down, then you don't really know what's going on, so you might as well write them down so you know what's going on, and you never have to deal with this again. Got that written down. Start at the right, side of your answer and put the decimal left the number of places from step number 2. Which means this. I got 3 for step number 2, so I start at the right and I come back 3 places, and that's where the decimal goes in my answer. It's 1.476. This is my answer. How about that? So that means this. Let me change this problem and make it this. Let me make it 0.36 times 0.41. Guess what digits I'm going to get when I multiply 0.36 times 0.41? Multiplying really the same thing. I am still going to get a 1476 when I multiply that out. It's the same two numbers times themselves. The only thing that is going to change is that decimal. How is the decimal going to change in this one? Well, I count decimal places. Now this is 2 and this is also 2 for a grand total of 4. So where in my answer is my decimal going to go? Kate?
Before the 1.
Right. You start at the right and come back 4 places. 1, 2, 3, 4. Common mistakes I see people make is they start at the left and go to the right. That does not help you out. You have to start at the right and go back. What if I took a decimal out? What if I made it 3.6 times 4.1? Guess what digits I'm going to get at the end? 1476. The only thing that's going to change is where does the decimal go? Charlie, the decimal is going to go?
Between 4 and 7.
Yep. Because this has 1 decimal place, that has 1 decimal place, that's a total of 2 decimal places. Means I come back 2 places. Now, Ethan.
Couldn't it be like infinite number since, well, say you had like
A bunch of zeros at the end of it? It doesn't matter. When you start putting a bunch of zeros at the end of that, that's going to give you a bunch of zeros here, and that's still going to end up being right here. Is that what you're asking?
No, I mean on the left.
On the left of what? But see, zeros on the left of this don't matter because you're only starting at count how many on the right side back it is. So zeros over there don't make any difference whatsoever. Let's look at a couple other examples from the book here. Where's the problem in this lesson? No? So here, right from the book. 1.5 times 1.5. What do you get if you multiply 1.5 times 1.5? Do that one for me just relatively quickly. Sam says,
2.25.
let's check. 1.5 times 1.5. And again, this is just coincidence that that decimal lined up. It's not going to line up in my answer. 15 times 15, 25, 2, 75, 0, 15. I get 225. There's 1 decimal place there, 1 to the right there for a grand total of 2, so I come back 2 places. 2.25 is my answer. Everybody pretty clear on that?
Yeah.
Don't let these sort of things fool you, because this, I can tell you, you'll get this wrong. How about this? 1.2 squared.
Oh.
Don't forget what squared is. It just means you are going to take 1.2 and multiply it by 1.2. What is 1.2 times 1.2? Leah?
1.44.
Yep. 1.2 times 1.2. 12 times 12 is 144, 2 decimal places. 1.44. Shop, bam. Alright, enough of me fucking with you.